Welcome to Advanced Image and Video Processing Lab for Research and Skill Development. In this lab, we are going to demonstrate you this Advanced Image and Video Processing board. The first thing we will show you what are the different components and what do you get with this board. Okay, so let's begin with the power supply. This board contains a 12-volt power supply. Then next to it there are two antennas, as you can see. They are for Wi-Fi and Bluetooth. Afterwards you can see there is one single USB host. Now since you need to connect lot of devices, USB devices such as keyboard, mouse, camera, so we use some sort of USB hub, as you can see in the side of this video. Okay, so this is very essential for it. Afterwards, next to it you can see there is a HDMI output port for HDMI display. Then for storage there is a SD card slot. Afterwards you also have a Ethernet port, which will be very useful if you are connecting IP cameras or internet connection. Then there is this CAN connector, so if you want to use automobiles protocols such as CAN lane, so this connector will help you do that. Afterwards you can see there is a connector connected, which is for SSD hard drive, and this SSD hard drive is optional for this lab, but this hard drive is very essential if you are opting for deep learning lab. Okay, we will talk about this much more in depth later on. You can see there are these 4 switches for controlling the board, shutting down, switching on, or putting the board in flashing mode. Okay, if you want to flash the board with different sort of operating systems. Then you can see there are 2 GPIO pin connectors, which contains lot of protocols within it, like I2C, SPI, CAN lane, UART. Okay, so you can connect sensors through it or any sort of input or output devices with that. And the most important thing, this board comes with a 5 megapixel fixed focus camera, which is directly connected to the board itself using CSI MyPi interface. And the benefit of this is there is a language supported on this board which is called OpenVX, and which is similar or language sort of like OpenCV, but it's more on hardware processing. And since this camera is on board, you can take benefit of hardware processing or image processing. Okay, then next to it, finally you can see there is a display connector. You can connect some LCD sort of displays. This is what you can say, fan sink is provided, and underneath it the main SoC or the main controller of the board is provided, so which contains a processor and a GPU, and as well as the onboard flash and all other components. Okay, so that's it for the board introduction. Now we'll begin with demonstrating you the examples and what you can do with this board. Okay, now there are 5 sort of categories you can distribute. As you can see, we have providing the documents, and we will go through this later on as well. So the first thing we'll talk about is what you can do with this board. The first thing we can do with this board is generating graphics. Since this is a GPU board, so the main power of this board is graphics. Okay, but with graphics you have 2 options: either you are generating or either you are processing it. Okay, so the first part is generating the graphics, which is OpenGL and Vulkan. This is the Vulkan one. Okay, so these are 2 languages which are predominant in our graphics development. OpenGL contains 2 parts. One is OpenGL standard, and one is OpenGL ES, which is embedded systems version, which we use in our mobile phones. So whatever rendering, whatever games, whatever play in our mobile phones are rendered using OpenGL ES. Now Vulkan is something new. Currently it's getting developed, and the benefit of Vulkan is it has only one standard API for both desktop as well as mobile. So whatever code you write for the desktop can be ported to your mobile phone. So it's what you can say, you will get high efficiency, and it's made for the newer kind of hardwares that are available on your today's modern phones. Okay, such as GPU, multi-core processors that you get in your mobile phones. You get higher availability of RAM, so you can use those features by this Vulkan language, and that's a benefit of it. Then you can see we have support for OpenCV. This is software-based image processing supported. Then we have this VisionWorks framework. This VisionWorks framework uses the language called OpenVX, and OpenCV together to give you a hardware image video processing, so you get higher frame per second rate of the videos. You can connect a very high speed machine vision camera of 600 frames per second using this language. Finally, you have CUDA. Now CUDA is nothing but whole platform of this board. CUDA is a parallel programming language for GPU, and through which you can parallelize any applications. Now let's begin our demo. First of all, the examples of OpenGL. So you have to go in graphic samples, binary, and here are all the examples. So let me show you a few examples. Let's begin with compute particles here. So as you can see, these are very simple simulation examples of rendering heat particles and the motion of these particles. Okay, so these are all computed and rendered using OpenGL. Afterwards, the main facility of OpenGL is to render the light, how the light is reflected, absorbed. And to show you that example, we have a very nice example of this model here. It's a small model, and you can select the type of material you want. So here currently you can see it's a diamond material, and there is a lot more refraction going on from the diamond. There is very little reflection going on from the diamond wherever the light is reflecting on it. Source of lights are at the top of it. You can see. You can change the material. Say if you take the matte, it gives the soft shadows. It absorbs more light and it's glowing more. Okay, if you want to see this sort of material properly, you can change the environment, and now you can see the matte is much more visible here in this environment. Okay, so the whole benefit of using this graphic language is it provides you rendering using both ray tracing and currently multiple optical ray tracing. Okay, so these are few examples of OpenGL. In OpenGL itself, there are some examples provided for OpenGL ES, which are the embedded system version for mobile phones. Okay, and now let's take a look at Vulkan examples. Now Vulkan examples are provided at the bottom here. Let's open them. Go to the build folder where we have built them. Go into the bin folder, and here we have all the examples, and you will see these are the same examples which we have provided in OpenGL as well. So you can see the comparison of those examples and these examples. Okay, let's begin with some examples such as HDR example that we have seen in the OpenGL of the different materials, teapot and so and so. So let's take a different shape like sphere, and you can see how the environment is reflected on this metal body. Okay, so this is not absorbing. When it's a metal, it's only reflecting. There is no refraction going on, so it's a pure reflection. So the material is decided how it interprets the light. Okay, and we have provided more of this similar example in both OpenGL and in Vulkan, so you can take comparisons and you can learn how they are programmed. Now let's move on to next programming language. We talked about CUDA. So CUDA is the base accelerator through which you accelerate every program. It's the parallel programming language through which you can parallelize anything, whether it's OpenGL, Vulkan, OpenCV or OpenVX. CUDA is at the base of everything. Okay, now CUDA samples come with some predefined categories. First are these simple categories which contain some simple examples to get started with the CUDA language. Then there are these utilities examples which you can use to do device query and bandwidth test. Then we have some graphic examples which shows examples of the OpenGL which we have just seen. So they are the same examples. Then we have some imaging examples. Imaging examples are nothing but image processing examples which you do with OpenCV or something like that. I will just show you one example like this. So you can see a simple box filter example, but the filtering is happening with parallel programming of the CUDA rather than the OpenCV. Okay, then let's get out of here. Here you can see some finance examples are provided, some simulations are provided. In simulations, some fluid examples, n-body simulation is provided. Let me show you a few of this. So n-body simulation is kind of a simulation used by the Brownian motion algorithm of what Einstein created. So it's using that same example for the working with the gravity and the chaotic motion. These are the main examples of simulations. Then we have category called advanced. This contains some advanced examples of CUDA. And finally we have a CUDA libraries category. So a lot of CUDA examples you have to write the CUDA kernels by yourself, and it depends on how efficiently you write them. So what these people have done, that CUDA they are providing you a lot of libraries which can accelerate or which can help you use certain function directly, and you know these functions are optimized for you, so you do not have to worry about optimizing every small functions. So this is the base of it, and this will contain the examples, demo samples, so you can get started with it. Next category is our image processing. As we said, image processing comes to two categories. One is software based image processing. That image in OpenCV, there are some examples which are by default provided by the OpenCV itself. In the samples folder you have examples running CPU, so there are quite a lot of examples to run with CPU, and lot of examples which shows how to use CUDA GPU to running with OpenCV. And we have also provided some few examples to get started with the camera, onboard camera of this board, as well as if you connect some USB camera, then also how you can use them with this OpenCV. Currently the view you are seeing here is using a USB based camera, so we will show you how to do them. Okay, let's take one example here, say descriptor matching. Okay, so let's show you descriptor matching example. Okay, and this descriptor matching example will demonstrate the onboard camera of this board, which is a 5 megapixel fixed focus camera. So let's run this example, build CV and enter. So now you can see the example is running, the window is appearing. First you have to provide some small section of object to this camera. So we are bringing the object within the blue square, then we press the R key, and now it will track the object. You can see it is tracking the object feature points that he has located. Okay, so once you give the sample object in that region of interest, and it starts to track the features of it. Okay, so this is one example we have provided of how to use camera into your own algorithms. Then let's take a look at some other example here. Then we can see foreground background segmentation using GPU. So how to use GPU or CUDA programming into OpenCV, we have provided one example, and this example, rather than using camera, we are providing a fixed video to it, okay, of some people moving around in a CCTV camera. Okay, and it will able to separate the background and the people from it. Okay, so let's run this example. Okay, there you go. So as you can see, it is providing you 4 views, and here you can see these 4 views. I will arrange them. So here you can see the 4 views of the video. This is the original video that is going on. This is the mean background image that is getting created. So it is subtracting the people from the original video, and the subtraction is happening using this foreground mask. The better the foreground mask gets, it will subtract the foreground mask from the original video, and you will get this mean background image. And it will also separating the foreground mask image, which are the people, and those were going on. The script exited by itself, and you can see here the frame per second that was happening with the processing. With the background foreground segmentation, you are getting this much frame per second, and this is because we are using the GPU for it. We have provided an example which is not using GPU, and you will get barely 8 to 10 frame per second with that. So this is the benefit of having a GPU and CUDA parallelism. So you can get higher frame per second, you can basically accelerate anything. Okay, so that was that. Now let's take a look at how we can use a USB camera. So since we are using USB camera to show you this board, I will now close this, and we will run this example to show you the USB camera. Okay, so this is a very simple image processing algorithm of Laplace. Let's run our example, which will do Laplace processing using USB camera. So you can see this is our board image again. We can try change the factor or parameter of the Laplace, which is the sigma parameter, and as we change, you can see how it's doing the processing meanwhile. Okay, so these are some very few examples, and the whole the idea here is to show you how to use basically the onboard camera as well as the USB camera with your OpenCV. We have also put some few examples which in OpenCV are the examples of machine learning. Okay, so here is again background foreground segmentation, but this is done using a machine learning algorithm of KNN, which is K nearest neighborhood algorithm. So you will better understand if you run it. So as you can see here, I have run this example. First you have to select the area of interest that you want to select. Here I am selecting a flower. The majority in this area of region is the flower and the yellow color and orange color. So it detects that this is the actual object, and it will determine that by finding the neighborhood pixel, and it will say that the majority of the pixel is the flower, or the yellow pixels more are of the flower. So it will remove the green pixels. It will give less importance to the green color, and it will subtract green color from this. Okay, and you can do this by pressing N here. And as you press N here, it will try to determine, and it will improve the number of pixels to do the classification. And it will do the classification which is a background image and which is a foreground image. And you can see as you press this N, it will show you the iterations or the number of pixels you are increasing per iterations. Okay, so this is how you can also implement machine learning algorithm, which is a part of OpenCV, and you can do examples like this. Okay, so let's exit this example now. So that was regarding software based image processing. Now we will take a look at hardware based image processing, which is VisionWorks. Okay, so VisionWorks is nothing new. It's not something that you will get to do some hi-fi examples. It is the same examples that you have done using OpenCV, you will get to do with VisionWorks. It provides all the API that you can get in OpenCV, but in VisionWorks. So the programming is different, but the benefit is you will get very high speed frame per second. If you are using very machine learning cameras which have 600 frame per second kind of that, then you have to use VisionWorks for that. Okay, you cannot rely on software processing, otherwise the accidents or something like that may happen. Let's run some examples here from the VisionWorks. So let's take some feature tracking demo. Okay, which we will run some feature tracking demo, which will track, first it will do the feature detection and then it will track those feature. Okay, so let's run this feature tracker on using our USB camera. Okay, so I am taking a USB camera here for feature tracking. Okay, so here you can see the feature tracking using the USB camera, and we are able to track the feature here. I can also show this with onboard camera, so I will show you the same example using onboard cameras, and you can see you will get a much higher resolution and much faster processing here. And you can see the direction it is tracking the object. Okay, next let's take an example of simple like how this works with CCTV camera. So there is a simple example of motion estimation. So let's run that NVX demo motion estimation, and right now we are feeding a video feed from the CCTV camera, and as you can see it is able to track the motion, only the moving objects which are moving and the direction in which they are moving. Okay, and you can say the frame per second that you are getting, averagely 60-70 frame per second you are getting in that. Other thing, this can also help you work with stereo cameras. If you're using any sort of depth camera or even like heat cameras, you can use that. Thermal cameras, you can use OpenVX with them. So very simple example of stereo matching is provided. Some stabilizer are also provided. So these are the same examples that you can do with OpenCV, but with higher processing speed. Okay, now finally we will also show you some examples which are just demo examples for this VisionWorks. This is a very simple object tracker, but it tracks the object in real time. The thing is, it takes the region of interest in real time. Say, so now if we define I want to track this car, I will select this car and it will start to track this car. I want to track this car as well, it will track this car as well. So you can do some multiple object tracking using this, and this cursor selection is happening because of we are using OpenGL with this OpenCV programming. So this is a very simple example of multiple object tracker in runtime. And now finally we will show you how to work with all of this. You have seen us running all these examples, but how to compile them, how to work with the ecosystem, how to build them, how to debug these examples. So we are providing the documentation for that. Let me open a CUDA documentation here. So here I am opening the CUDA documentation. As you can see, and this documentation will include from start to end how to compile this example, how to build this example for yourself with the ID they have provided. So this ID is provided in the host system, and we provide a hard disk that you have to plug into some sort of PC, and that host system will then run this ID into it, okay, which you can then connect to our board of the GPU board and then debug it. Okay, so these are the steps for building it and debugging it, and we have provided all the screenshots and what to expect from those screenshots. Okay, so all the explanation is provided with it. And the hard disk that you are going to connect with the host is a part of accessory which you will get default with the board itself. But you have to remember, we are not talking about the SSD we showed earlier. That SSD is optional for this advanced image and video processing lab. Okay, this was CUDA document. Let me show you one another document. Let's say I show you OpenCV document, which has lot of example we have just seen. So as you can see, all the steps are provided, how to go to the folder, how to build the example, and how to run the example, and with the output of the example, okay, and the explanation for that. Okay, so here you can see we have provided all the explanation for all the examples, and similar are provided for other languages as well, for whether it's a VisionWorks, OpenGL, or Vulkan. So, and this is it. So we have shown you just the examples that are related for the advanced image and video processing lab. This board does support for deep learning, machine learning inference, but the training has to be done from your server. Okay, this can do the inference, but the training has to be done from the server. So again, I will remind you that this is our board, and the hard disk you are seeing here, the SSD drive, is an essential part of the deep learning setup, but it's optional for the advanced and video image processing lab for skill development. If you have any doubt or concerns, you can contact us at info@edutechlearning.com, and our website is www.edutechlearning.com. Thank you.